So then my period is 2 pi, right? So where it repeats, I don't know where the recording stops. So it's going to be 1, 2, 3, 4 quadrants. That's going to repeat itself. 1, 2, 3, 4. You don't have to go from 0 to 2 pi. You can just say, look, 1, 2, 3, 4. 4 quadrants is 2 pi, so this repeats itself. 1, 2. So it is still 2 pi. Okay. Asymptote. So this one's a little different. So all that's changed is that we've shifted the graph over. So from the sine graph, my asymptotes are no longer at, what did we have? We had it at every k pi, where k is, right, element of, and then we're trying to use z, right, instead of the integer thing. So z, that stands for integers. So that. Now, it's not every pi. It's every, what are these? So if this is 2 pi, that's pi. This is pi over 2, right? What's this one? 3 pi over 2. What's the pattern? What's the next one going to be? Is it going to be 5 pi over 2? You're adding halves. 1 half, 2 halves, 3 halves, 4 halves, 5 halves, right? So each one's a half. Half, 1, right, pi, 1 half, 2 halves, 3 halves, 4 halves, 5 halves. So our asymptotes are at the 1 half, 3 over 2, pi over 2, 5 pi over 2. What do we notice about that pattern? That these guys here, right, they're odd numbers. Not the 2 over 2, right, not the 4 over 2. They're odd numbers. The way that we asked you to write odd numbers, and I know because I just taught this to my grade 11's the other chapter, we asked you to learn that odd numbers, so remembering here, odd numbers, we asked you to know that that was going to be, and I think we use 2, we'll use k plus 1. Right, so 2k plus 1. And last year we taught you when we did word problems, we said try to use 2k, 2x plus 1, because that represents any general odd number. Where k, and we didn't make you state this last year, but where k is an element of the integers. Right, so any integer you put in there will always result in an odd number. Yes?
Could you also write it as pi over 2 plus k pi?
Pi over 2 plus k pi. Oh, yeah. Which is what we're doing, though. So when you, okay, so when we put that in, right, so if I go 2k plus 1, and I'm going to say it's the same thing, right? So you're distributing like that? Yeah, say same, yeah. So exactly. So they're saying, okay, so let's write it this way. So I'll write it this way because people just see the odd number. So they're going to go x equals. Don't forget the equals. This is such a wasted half mark. Right? Remember, asymptotes are always equals. Then I'm going to go 2k plus 1 pi over 2, where k is an element, right? And then we're using, whoops, sorry. Do my z's funny. Like z. Which is, if you do this on the side here, I'll pull this, we have so much room down here, I'll pull this down here, or you can go 2k plus 1, and then you're saying, yeah, you distribute it, it's the same thing. Sorry. So you could do this, distribute that in, and you're going to get 2k, I'll slow it down, over 2 plus pi over 2. And you're just distributing the pi, so 2k pi over 2, pi over 2, and then you went, wait, and then I canceled the 2's out, right? So that's k pi plus pi over 2, same. So you're saying it's an even number plus a half. Yeah.
Why did you put it over 2?
Oh, why did I put it over 2? Oh, because it's the number on the top is odd. So it's 1 pi, 3 pi's, 5 pi's. So the number on the top is the odd number, and over 2, yes. Yeah, so the number on the top is odd, so 1, 3, 5 pi, and then on the bottom is always 2, so I put the 2 there.
It doesn't matter if you plus or minus.
Yeah, plus or minus, it doesn't matter. So 2k plus 1 or 2k minus 1, same. Yeah, so the definition of an odd number is either 2k plus 1 or 2k minus 1. Yeah, which is the same, and then when you break it apart, it's the same. So either one of these, gorgeous, but I want you to be able to write an odd number and an even number, right? So, and that's why we started that last year a little bit with the odd and even, because before it was like x, everything's x. It's like, technically you can, clarify that a bit. Okay, so that's better. Okay, so if you don't understand this one with the distribute, then just write it this way. It's odd number k pi over 2, right? So that matches these guys here. Is that okay? That's, I think, the hardest part. Okay. Max value, none. We're okay for that. Min value, none again. Domain is going to be everything. And look, we just grab here. So if you have whatever your answer is from there, you're saying don't touch those. Right? So this relates to this. Always domain relates to your asymptotes and holes. So you're going to say x is an element of real, but x cannot equal here. So whatever you put there, whether you put this form or that form, same. 2k plus 1 pi all over 2, and k is an element, right? Z? I try to do the double Z because that's what I always trained. I always had a hard time with that one. Okay, and then close that up. And your range is going to be y is an element of real, and y is less than or equal to -1, or y is greater than or equal to 1. Okay, any questions or clarification?